Hello everyone. In this video, we'll understand about arithmetic progression. So what is arithmetic progression? A sequence or a series which has a common ratio. I'm sorry, common difference. I should say different, not ratio. Common difference for successive real numbers. A sequence or a series which has a common difference for all successive real numbers. For example, I can say 3, example 3, then I will say 7, then 11, then 15, likewise. This is an arithmetic progression, or we can call it as arithmetic sequence having infinite terms, because it is not ending. Infinite terms. Why it is arithmetic sequence? Or because every term is being segregated or separated by commas. So sequence, it is separated by commas. And for example, I may write one more: 2, 5, 8, 11, and so on. And instead of so on, let me end it. End it with something. 14, 17. This is arithmetic progression, or to be very specific, arithmetic sequence, again having finite terms. In the first example, this is the first example, this is the second example. In example 1, what is the common difference? Common difference is term 2 minus term 1, which is 7 minus 3, and it is 4. Term 3 minus term 2, it is 11 minus 7, it is again 4. Term 4 minus term 3, it is 15 minus 11, it is again 4 only. So everywhere the difference is the same. That is why you say it is a common difference. Generally, this common difference is denoted by T, right? Okay, in the second example, I'll say example 2, we may notice term 2 minus term 1 is 5 minus 2, it is 3. Then next, term 3 minus term 2, it is 8 minus 5, it is 3. Term 4 minus term 3, 11 minus 8, it is 3. Term 5 minus term 4, 14 minus 11, it is again 3. Even the last, that is term 6 minus term 5, 17 minus 14, it is again 3. So all these are differences same. You call that as small t, which is the common difference. Now, same example, if it is written like 3 plus 7 plus 11 plus 15 plus and so on. We call this as arithmetic series. arithmetic series whose terms are infinite. It is because it is put as dot 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 dot. That means it is the number of terms are infinite. Then in the second example, 2 plus 5 plus 8 plus 11 plus 14 plus 17. This is finite arithmetic series because it has got finite terms. Both of these can be again said as arithmetic progression. Sequence or series both can be said as arithmetic progression. Why it is series? A series will be separated by addition symbol between each term. Then you call that as a series. Now, in general, an arithmetic progression can be expressed as first term. If I call it as A, then the second term will be A plus D. That common difference is getting added. Then A plus 2D and so on. This is term 1. This is term 2. This is term 3. So I can say now term n minus 1. If you look into here, term 1 means there is no D. Term 2 means there is 1D. Here it is 2D. That means term n minus 1 should be A plus n minus 2 times D. Similarly, A plus n minus 1 times D will be your term n. So I can say in general, Tn is our nth term of an arithmetic progression. It is given by A plus n minus 1 times t, where A is the first term or term 1, n is number of terms, t is a common difference. Now, let us understand another one. So I can just put here this as a formula. Nth term, if I want to find for an arithmetic progression, I can use this formula. Right. Now we'll understand about sum of first n terms of an arithmetic progression. Means what we are talking is A plus D plus A plus 2D plus and so on, A plus n minus 1 times D plus A plus n minus 2D. Here I will write n minus 1 times D. We are talking about this. This is denoted by S suffix n, means sum of the first n terms. So if I want to evaluate this, I will first add all these A's, this one, this one, this one, this one, this one. How many A's are there? There are n A's. So I can write n times A. Now if I consider this, D terms, first one is D, then 2D plus and so on, n minus 2 times D plus n minus 1 times D. Everywhere you may notice D is common. I can take D outside, so I can write it as 1 plus 2 and so on plus n minus 2 plus n minus 1. We know in if a terms are having like this 1 plus 2 plus 3 plus and so on up to r, then I can write down the formula as r into r plus 1 by 2. So here we will be using that particular formula in this. Here instead of r, you may notice it is actually n minus 1. So I can write Sn as n times a plus d times. So instead of r, it is n minus 1. That means n minus 1 times n minus 1 plus 1 divided by 2. So this minus 1 plus 1 gets cancelled. So I can rewrite my Sn as Na plus d by 2. Here it is n minus 1 into n. Now if I consider this 2 as LCM, 2Na, let me take 2 as LCM, plus let me expand this, then it becomes d times n square minus n. So that can be again rewritten as, we may notice I can again write this as n square minus n. Yeah, I can keep n by 2 times 2a plus n, I mean, instead of expanding it, I can retain as it is. No need to confuse. Here, n into n minus 1. So what I did is I took n by 2 outside. So 2a will be the first term. Here it will be 2a plus n minus 1 times d. That will be the sum of n terms, first three n terms, right? Now, I can write like this also. So I will put one formula like this. Let me put that in box. So in short, Sn can be evaluated as n by 2 times 2a plus n minus 1 times d. That is one part. Then further, I can again write this Sn as n by 2 times 2a plus n minus 1 times d. This can be splitted as 2a can be written as a plus n minus 1 times d. What is this? This is actually our nth term formula. I can write that as nth term. And again, that can be written as a plus L. What is L? If nth term is the last term, then it is denoted by L. That L is getting replaced for Tn here. So this I can consider it as another formula. In case if we are aware about the last term, straight away we can substitute this formula rather than doing the first one. This is one formula. This is another formula. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends and also subscribe to my channel. Thank you.